In this video, we're going to continue talking about functions, and we're going to look at specifically about how to incorporate parameters and return values into functions. So previously, we've seen how to create a function that outputs a 5 by 5 pattern of stars, and this is what the function looked like. So we named it print stars. And and then the function has nested loops. So I controls how many rows we have, and then the j controls how many columns of stars we have. So since they both I and j go up to 5, the result is going to be a 5 by 5 pattern. And then just to recap, we call the function by name. So right over here, print stars. And when we do that, control is transferred over to the function, which means that the statements in the function are going to execute one at a time until function reaches the end, and at which point we go back to the calling context, where we call the function from. And the Python continues the execution from that point on. Okay, so now let's suppose instead of having the function output exactly the same thing every time, we wanted to output a square pattern of any dimension. So of dimension dim by dim or n by n, whatever, however we want to refer to it. So in order to achieve this, what we need to do is we're going to modify the function so that it accepts a parameter, and the parameter represents the dimension of the square of the pattern that we want to output. Okay, so let's take a look at what that would look like in code. So here we've introduced the parameter dim, and the way we're going to think of this is just simply that dim is just a variable that the function print stars has access to. Now before we step through the code, let's see what the value of that variable is going to be. Well, the way the value of the variable is determined is by the argument. So when we call the function now, we're gonna supply it with a value. So that value, the argument, is essentially passed to the function. So here the argument has to match the parameter. So in this case, dim as a variable takes on the value 10. And then from that point on, the code executes. So for I in range dim, which is 10, so in this case, that's the number of rows that we have, and it's the same for j, which is the number of columns, so dim by dim. And then we execute it, we see we're gonna get a pattern of 10 by 10. So let's give that a try. So here I'm gonna execute this again, and then we get a 10 by 10. But if I were to do 3, print stars 3, it's gonna output 3 by 3. So it did what we expected it to do. Okay, so in essence, what we've done by introducing parameters is that the function now is more general in that it acts based on the input we provided. So its behavior is dependent on the input we give it, as opposed to the earlier example where the function does exactly the same thing every time we call it. Okay, now let's take this a little further. So what if we want to output a rectangular pattern instead of a square pattern? And the dimension of that pattern is some number of rows by some number of columns. Okay, well, how would we do that? Well, here we go. So instead of having single parameter, dim, we're going to define two parameters, rows and columns, and then we're going to modify the code and the function accordingly. So let's take a look at the code. Now, I should mention before going through the code, as we're going through this, I want to encourage you to type the code yourself and try it out, and then that way you have a much better understanding of how it works than just by watching the video. So pause the video to type the code yourself and make sure you could get this to work. So okay, so let's take a look at the function. So again, instead of defining a single parameter, we have two parameters, so we're going to represent those as variables, rows and calls. And if we look at the function call over here, here are the two arguments. So we send 9 over to the function, is passed over to the function, and 10 matches calls. So this is what we have. So rows is 9, calls is 10. And now again, the outer loop for I in range controls how many rows we have. So that's what we put over here. And then for the inner loop controls how many stars are in a single column, in a single row. So that's the columns. Okay. So let's execute this and make sure it works as we expect. So execute it 9 by 10. If I were to do 2 by 10, so we're going to see 2 rows, 10 columns. So you get the idea. Okay. So now the previous examples where we use parameters, they essentially illustrate the flow of information into a function. So that's what parameters allow us to do. But it turns out there are many occasions where not only we want to pass some data, some information to the function, but we'd like for the function to give us back the result of the computation. And as examples, functions we've used before, think of square root. So the way we call square root function, we say something like math.square root, and let's say we want to take the square root of 5. So that would be the argument, what we're passing into the function. So let's suppose we represent the function as a square. So we have flow of information into the function, and we expect it to give us back the result, the square root of 5. So we want to see how we get flow of information out of the function. So we have this taken care of using parameters, but now we want to focus on this part of getting information out. Now, as it turns out, this is a pretty straightforward process, and there's a keyword in Python that allows us to do that, and that is the return statement. So let's look at the details of how that would work. So the return statement accomplishes this. Again, return statement is about flow out. Let's take a look at an example that illustrates return. We're going to look at non-trivial example. Simple but non-trivial nonetheless. So the example we're going to look at is to write a function that counts the number of spaces in a given string. So given a string, so we think of the string as an input, we want to count how many spaces are in it. So before we start writing about the code, let's think about what is it that we need, what is the structure of that function. Well, first off, we have to decide what we're going to name the function. Now you typically want to give it a meaningful name. So in this case, count spaces makes sense, but you could think of others that would be equally meaningful. we need to define a parameter. So again, the input to the function is a string. So that's going to be the parameter, and I'm going to name my parameter S. You could name it str or something else, but S is okay. And then the function is going to return a value, an integer, which represents the count of spaces that is contained in the string S, in the input string S. Now some more details about how we're going to achieve this. Well, first, if we want to keep track of a count, we need to define a variable that we initialize to 0. So we're going to call that count. And then once we've initialized that variable, we're ready just to iterate through the string. We're going to iterate through our string S, which is our parameter, one character at a time. And then we're going to examine each character, and if it's a space, if we compare it to space, if it's a space, then we increment count. If it's not a space, well, we don't do anything to count. And then when we reach the end of the string, we simply return the count. Okay, so how does that translate to code? So let's take a look. So here's the function. S is our parameter. Count is initialized to 0. And using a for loop, so this is for each character in S. So S at any given point is just a character in the string. And then we're going to compare ch, our character, to a space. And if that evaluates to true, then we update count. We increment count by 1. So we iterate through the string one character at a time, updating count as we compare each character to space. And when we're done, we're just going to return the count. Okay, so let's see. So this is just a function implementation, and then we need to look at how we call this function. So given an input, this is a string, this is our input, this is our argument. We want to call the function count spaces. So now again, here we have the argument is a string, and that's what we're passing to the function. So S is, this is a string. And we call count spaces, and count spaces, where there's transfer of control, the function executes, and at the end it's going to count, 1, 2, 3 spaces. And so that's what count is going to be. And what we're going to do is save that value into that variable num of spaces. Okay, so the result is going to be saved in a variable. And then the next thing we do here in line 3 is to output the result. Number of spaces is 3. So here, let's execute this. And as we expect, it counted correctly that there are 3 spaces in the string. And if I were to add a couple spaces here and I execute this again, it does it correctly. So it counts those spaces as well. Okay, now so this is one way of calling the function. So in this case, we're actually saving the result and storing the result in this variable called num of spaces, but it's also possible to just not save the result. So in essence, I could just call the function. It gives me back the count, and I output it all in one step. So I'm not saving it to a variable. So this is, if I don't need to store it in a variable, then I could do just that. Okay, so this is an example of doing that. So essentially now the call to count spaces is an argument to the print function. So count spaces is called, it evaluates to 3 in this case, and that value is output. Okay, so let's execute that, and there we go. And if I were to add spaces over here, I've added 2 spaces, so there should be 5. Okay, so it works as expected. Okay, now just to recap, so functions allow for code reuse, right? So we write the function once, we implement it once, and then we could call it whenever we want by name. So that's a powerful concept. And then functions allow us to break down program into well-defined units of execution. So if you think of a function like count spaces, that's a meaningful unit of execution. We know what it does, and it's good practice to have a function do one thing and one thing only. So in our case, given a string, it counts number of spaces. That's it. So it's understandable what exactly it does. Now, and then 2 other important ideas that come with functions is that parameters allow us to embody the flow of data into the function. So this is how we pass data into the function, and then we have the return statement as a mechanism to allow us to get data back from the function, flow out. Okay, so with these ideas, with these examples, we basically have all the core concepts of creating a function. And in the next video, we're going to look at some other examples of creating functions, because it takes a while to, there are some other details that we need to focus on that are important. So we'll look at some more examples of that. Okay.